that I know of that have Xfinity, if you get a newer modem that supports IP, I hate the modem in quotes, if you get a newer gateway that supports IPv6, you will have native IPv6 access or dual stack. So that's out there right now in Michigan, works today. So they're the trailblazer, they're the furthest along. Time Warner is not too far behind, AT&T is not too far behind. I'll talk about all the major ISPs in the US. So this is all kind of going on quietly behind the scenes, right? So think about it, by June of this year, one of the largest residential ISPs in the US will have, all of their customers will have the capability of having IPv6. And as new customers, because people move around a lot, so as you move around, you get a new gateway, you order a new service, you're just gonna have it on by default. If you have Vista or newer, or a current version of OS 10 or Linux, you're just gonna have it, and you won't even know. So this is all kind of quietly going on behind the scenes. Another interesting question?
Yeah, I'm not familiar, what's CGN?
Good question. CGN is carrier grade NAT. So carrier grade NAT is when you have multiple layers of NAT. So for example, with Uverse, AT&T's Uverse service, because of IPv4 depletion, and AT&T can see the writing on the wall, if you get Uverse service, I don't know if it's all Uverse, but most Uverse customers, you no longer get a public IPv4 address. You get a private address, and so you have NAT at your home, and you have NAT on AT&T's network, or 2 layers of NAT. So CGN kind of causes some interesting problems, like, for example, let's say that I get a camera for, like a security camera for home, and I want to be able to log into the internet site and watch my security camera from home. That actually does not work with CGN. Right? This is a common problem, and if you actually search the CGN, it causes a lot of problems. So this multiple layers of NAT, it's actually causing real problems right now because we don't have enough addressing. So Time Warner they're also one of the largest residential ISPs in the US. They did a study about this, and because of depletion, it's basically what nobody's talking about is, let me ask you a question. So how many of you are going to give up your public IPv4 address and get a private address and pay more for worse service? How many want to do that? But the problem is, when the carriers deploy CGN, it costs a fortune. Because of all the legal, like CALIA, all the legal requirements, they have to log all this data. Now they have to include ports, so the amount of data goes up massively. It's incredibly expensive to deploy. So this is the other thing that is not well publicized, but if I'm a carrier, CGN is a fortune. And it's very difficult to charge my customers more money because nobody wants to pay more money for worse service. So it turns out it's actually cheaper for them to deploy IPv6. So that's a big part of, why do you think Comcast is so aggressively deploying IPv6? Because they figured this out 5 years ago. They're not waiting until their back's against the wall. So because of that, Time Warner is predicting the average cost of internet access is going to go up 13 to 21%, and it's going to accelerate IPv6 deployment. Originally, they were thinking by the end of 2014, most people will be deployed in the US. I think that might be a little optimistic, but you're going to see more and more of that pressure coming to bear. The other big thing too, that's also not well publicized, it kind of surprises me, is LTE is IPv6 preferred. Question?
So if I have a IPv4 address that I'm using, it's like a website, I'm using AT&T,
Mm-hmm.
are they going to force me off of that? Are they going to say, oh, you can't use that anymore?
So, some of their customers they have. And then basically if you want to keep your public address, you have to pay $15 a month, is the standard deal for Uverse. I don't know if that's in all areas, I know it's in some. But basically because there aren't enough addresses, so that's what the ISPs have to do.
Tying to his question though, the DNS, if he has a URL like gib.com or something, then once he gets the new address, the DNS will be updated and everybody will be getting to his website just like before.
If it's a public address.
Right.
Yeah. That's the problem with CGN though, is you no longer get a public address. So if you want to host a service from home, you would have to, well basically you won't. I mean the carriers aren't going to let you. So before, that's just a theoretical thing that most people haven't run into. But now, if you get, with the new service from AT&T and Verizon, if you get standard residential service, you will not be able, it's like a cell phone, you will not be able to connect your IP from the internet. 'Cause
Well,
you no
so my
longer have a
question
public
really is,
address.
are they gonna stop you from doing it? They're gonna tell me, sorry, you can't do that anymore.
Well, yes and no. It's not that they're directly stopping you, they're not gonna put a firewall in place, but because you don't have a public, so it's like this, if I use private addressing, it's not unique. So for example, let's say if I look at my address in the library at home, it's gonna be an RFC 1918 address, which is gonna start with 10, 192, 168, or 172.16 to 31. If I have an address in that range, and let's say I try and go out to Yahoo, I can make it to Yahoo fine, right? The problem is, when Yahoo tries to send traffic back to me, those are not unique addresses. So Yahoo's going, I don't know how to reach you, because you don't have a public address, right? It's kind of like if you're in an office behind a PBX, you might not have a DID or a directly reachable number. Somebody might have to call like your a main number and then dial an extension. That's how NAT was invented. It's modeled after a PBX. So when you lose your public address, you're no longer directly reachable. Your ISP would actually have to agree to do port forwarding, which they're not gonna do.
So what
So-
you're saying is someday it's not gonna work for me. They're gonna shut it
Well,
off.
with AT&T, they sent out a notice to all their customers saying you have to change to this private address.
Oh,
So, I
really?
mean, I don't think they'll just do it blindly.
I
You'll
haven't
get
gotten that.
communication.
You say that's already gone out, or?
There-
Yeah, it's been going on for over a year.
For years, we've been doing NAT at our own gateway in our house, right?
And you
So
still
they're-
will be,
Yeah,
but-
but they're moving NAT,
Well, you'll still do NAT at your house,
Right.
but you'll NAT from a private address to another private address.
okay.
My Comcast business is like that, where the modems are. I have to forward everything from the Comcast box. It's like a double net, it sucks.
Yeah.
Yeah.
But if you get Comcast Business, you can put it in bridging mode, which is what I do, so then you have direct control.
Hmm.
So, but you're losing that with double NAT, or with carrier grade NAT. So I'm more used to working on the networking side, so if I apologize if I put in acronyms or strange terms or something, please stop me and ask me. So for, the next big thing is LTE. So LTE or 4G is IPv6 by default, right? Because if you look at all the major standards bodies, they've seen the IPv4 depletion exhaustion, they've seen that coming 10 years ago. So they already planned for this. So LTE is IPv6 is the preferred protocol. So for example, if I get a Verizon phone with LTE or 4G service, I have native IPv6 access. I have a dual stack address. And if I get T-Mobile, the new Windows 8 phones, I don't think this is quite universal, but in most areas, I will also get dual stack connectivity. T-Mobile actually is IPv6 only. And this is gonna become popular because in the cellular world, a lot of the equipment, the way it works with PDPs, if you have two addresses, your licensing costs are twice as much. So some of the carriers like T-Mobile are like, well, screw that, so I'm gonna be IPv6 only, and then if you're using a T-Mobile device, or if you're using T-Mobile MiFi, you're basically going through a NAT64 gateway. So again, for web traffic, it works fine, but for anything else, like voice, video, Skype is a good example, are all incompatible with that. So some apps do not like NAT gateways. So, I mean, there's a lot of stuff like this going on, and this is always a good question for the skeptics that say, this is never gonna happen, is pull up your LTE phone and say, okay, I'm coming in from IPv6 and accessing your perimeter, so what's gonna happen? And usually get a blank look, because, you just haven't thought that far yet. So this stuff is out there right now. Right, so if you have, I know in Michigan, if you have an LTE phone, you will have dual stack, you'll have a native IPv6 address.
This does.
Okay, and then just, I won't spend a lot of time about this, but just to talk about some of the things with the Internet of Things. So smart grid is huge. So with smart grid, essentially all metered devices are gonna be on the network, which is a mixed blessing. But most smart grids, for example, Consumers Energy, I know from firsthand knowledge, are IPv6. So you're getting more and more of these IPv6 islands because anybody involved with the Internet of Things, again, I mean, they knew a long time ago that IPv4 is not gonna cut it. Right, I'm talking about a global pool of 100 billion nodes, and somebody's gonna tell me about a 4 billion node addressing system, I mean, you know, it's pretty easy to see that doesn't work. So most of this stuff is IPv6 only.
What's a 6 low WPAN? Does that matter?
So, a good question. So 6LoWPAN is, this is all under 802.15.4. So it's a kind of a low-speed wireless network, and Zigbee is kind of an alternative that's proprietary. So this is the open standard, and this is a way for all those sensors to communicate over IPv6. And the nice thing about 6LoWPAN is it's open. There's no licensing or anything like that. Versus, I don't want to pick on Zigbee too much, but if you look at Zigbee, it's closed and it also has a lot of security issues. And because it's closed, you can't publicly disclose the security issues, and there's really no motivation to fix them. So, like a good example of this is light bulbs. So there's actually a bunch of companies today, even like a bunch of people from Cisco created one, where they sell light bulbs that run 6LoWPAN. And you can manage all the light bulbs. You know, this is the Internet of Things. So for example, all the light bulbs in this room, all the electronics, I have a sensor network that I can manage. So this is the future, that all of this stuff, everything with power, is gonna be a node on my network that I can manage. Because think from a power point of view, if I have perfect visibility to everything that draws power, I can do some pretty cool stuff with power savings. And at any sizable company, you can save a fortune. If you can cut your electric bill by even 10%, I mean, if you have a data center, I mean, that's a small fortune.
So, on the lights now, you're gonna be addressing individual bulbs
Yep.
and determining which color you want, the
Yeah.
whole spectrum
Yep.
of color.
Yep, that's right. Those are out right now shipping. So I mean, that's the thing is, you know, if you open your, if you kind of, you know, open your imagination to the possibilities, I mean, essentially anything with power is eventually gonna be on the network. That's why we need a better addressing system.
Jim,
Yeah.
the other Jim here. Dropping into nostalgia a little early, I actually recall at one meeting in '86 or '87 where you passed the comment, "Hey, I need an IP address for my toaster."
Yeah.
Looks like you got your wish.
I still need a new toaster.
Yeah, no, toasters are going to be expensive.
Yeah.
We've got IPv6
The
attached.
electronics will cost more than the heating element.
Yeah, it seems to me it was like around 92 or 93, they were really talking about running out of IP addresses.
Yeah.
Before they started.
That's before Cider,
Cider
NAT,
blocks and
and
stuff, yeah.
there's one more thing, and Subnet.
So they figured out a way back then to
To stretch it.
overcome it, but I don't see them doing it again.
They
No.
were just patching what they
Yeah.
had. Right?
It's all right.
Yeah, no, it's too oversubscribed. So, and the other thing too is there are some ideas of, well, what if I have 2 or 3 layers of NAT and I have this port communication protocol, so I can signal routers ahead that I want this port to be forwarded to kind of stretch the life of IPv4, which is possible, but here's the problem with that. If I want to change any standard for the internet, for home electronics, for anything like that, typically, historically speaking, for me to invent a new thing until the time it's like on the shelf at Best Buy, usually takes about 20 years. Now, you could say that we've gotten twice as good, and this is probably a stretch, maybe we can cut that down to 10 years. But do you see the problem? We don't have 10 years, right? To get all the major vendors to agree on a standard, to actually develop it, write the code, develop the products, market them, actually get it out, get it running, work through all the bugs, it's a very long process. So that's why, you know, you still hear this stuff about, oh, we're gonna come up with this. I mean, it's too late. There's just not enough, we don't have 10 years. I mean, even three, I don't believe. I think maybe 2 tops. All right, so June of last year, we had World IPv6 launch. So this was interesting because a lot of major sites turned on IPv6 and actually left it on. So right now, if you look up Google or Facebook, even if you're on an IPv4 only connection, you will get back their public IPv6 address. So there's a lot of sites like this. This is active right now. Not getting it? Unless, I guess the only thing is if they have like a basic embedded system that doesn't understand v6. it's possible. But like if you're using Bind, if you're using Windows DNS Server, even back to 2000, BSD, anything else, you'll get it. So like try it from your office.
Yeah.
I'm tempted to try it now, but I don't want to. I'll come back to that. All right, residential ISPs. So if we look at the largest ISPs in the U.S., so this is any ISP with over 1 million subscribers. Most of them are pretty far along in deployment. So Comcast is almost done. Time Warner's not too far behind. AT&T doesn't have a date, but I know they're really far along in their deployment. Verizon and CenturyLink, which also includes Quest and Savvis they acquired, they're all pretty far along. Charter is also making good progress. Cox, I think they have their infrastructure set, but they're dragging their feet a little with residential rollouts. They're saying trials this year. Cablevision, Frontier, and Windstream, which these are kind of the, what's a nice way to put it, the price-conscious ISPs. They're more closed with their plans, but I know they're all offered on the business side. So, but if we look at all the largest ISPs, they're pretty far along. So again, kind of quietly behind the scenes, all this infrastructure is getting rolled out. If we look at the Tier 1 ISP, so a Tier 1 ISP the Tier 1 ISP are basically the internet backbone. This is the global internet backbone. So if we look at the top 20 ISPs, they are done. They are fully deployed. So they can route IPv6 fully across their networks. Okay, so in terms of content providers, so Akamai is the big name in terms of providing content. They support it. They route 15 to 30% of the world's web traffic, so that's pretty big. In the U.S., if we look at the top 5 sites, and Wikipedia being 6 is not a typo, the 5th site does not support IPv6. So if we look at the top 10 sites, 5 of them actually support IPv6. So this is interesting because the majority of the top sites support IPv6, where Comcast and AT&T enable native IPv6 access, they see 40% of the traffic switch from IPv4 to IPv6. So it's pretty good right now if you have access. Netflix is IPv6, which is kind of interesting because they take up to 1/3 of the internet backbone traffic in the US. And if we look at the global Alexa 500, 22% of them have IPv6 up and running. So it's actually it's pretty good progress. All modern operating systems have native IPv6 support. I wouldn't call Windows XP modern. It doesn't have it on by default. It is still fairly popular, although 7 outpaced it last year, so that it's going to kind of slowly fade away. But other than XP, everything else, Vista newer, OS 10 I think has had it since 10.3 or 10.4, and Linux has had, at least limited for a long time, over a decade. So all the modern operating systems have it, and it's on by default. Okay, so just a couple of charts. If we look at prefixes, so prefixes are autonomous or independently administered networks, and in the IPv4 world, we're at a little over 400,000. In the IPv6 world, I think we're at globally like a little over 40,000. So it's about 10% of the global networks have IPv6 enabled. This is showing within the U.S. This is in the upper left-hand corner. I think actually this is a little older. I think now it's up to like 11,500 in the U.S. But it's like I think it's about 11% of autonomous systems in the U.S. have IPv6 set up. This is the most interesting one though, is Google. So Google tracks 2 statistics. They track how many people globally can reach them via IPv6 and how many people in the US. So this is globally. And as you can see from the slope, since 2010, but especially this last year, the traffic is growing geometrically. So we're already at about 1.1%, which might not sound like a lot, but it's significant. And if you look at the US, it's double. The the number of people in the US that have native IPv6 access is at 2.2%. And this is growing 150% annually. So I don't think that will maintain, because if that maintained, we'd have 100% IPv6 by 2017. And I don't think it's going to be quite that ideal. I think it'll drag out a few more years than that. But the growth is there. So if you actually make a point of watching this, it's going really fast. So So this is for the US. The rest of the world is gonna be probably a year behind. But this is what we're